hyperbolas. Like I said, they're either going to be going left and right, or up and down. What's going to happen here? Yeah.
I'm just wondering about that you can make every single cursive letter using a hyperbola, some type of hyperbola.
Probably. Okay. We'll go on from there.
It wasn't we, it was we.
I know. You don't want any part of this one, right?
Put that,
Now, again, what's going to happen when you're looking at a hyperbola, you're still going to have vertices. You still have vertices with hyperbolas. And just like we said earlier, the vertex or the vertices always look at the focus. So your focus will be within the curve. What's going to be a little bit different, though, with the hyperbola is that the hyperbola are going to have what are called slant asymptotes. The slant asymptotes come across like this, or like this. So there's a little bit more work involved in order to set up a graph for a hyperbola. But after you set them through once or twice, you'll find out that it's so unbelievably easy to work with. Just like you noticed with the ellipses and all that. So the goal today is we're just going to go through a couple examples of how you graph them, how you pull out the parts, the vertex, your co-vertex, the focus, how do you get your asymptotes. And then from tomorrow, or excuse me, on Thursday and then Friday, we'll start shifting everything. We'll get through all, this is our last one of the generics, and then we'll start the shifts. And that's where things get messy. So let's look at the generic form of a hyperbola. Oops. When we're looking at a hyperbola, like I said, you're either be left or right, or up and down. The difference between the hyperbola and an ellipse is going to be really, 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 really obvious.
plus. I was thinking of how you find a C. Am I right?
There will be something different with that, and we'll talk about that here in a second.
Because don't you minus for C? No. No. Yeah. Yeah. No. Except that's A squared minus 1 squared. I'm just gonna stop.
What I've done here is I wrote the two equations below the directional ones. So if you're going left and right, it's x squared over a squared minus y squared over b squared equals 1. If it's going up and down, then it's y squared over a squared minus x squared over b squared equals 1. Notice how the a's and the b's didn't move, but the x's and y's did. So that's how you're able to tell which one is which. When you're dealing with an ellipse, the a squared term was always larger. Here it doesn't matter. A squared and b squared, it doesn't matter which one's bigger, which one's smaller. What matters is what comes first, the x squared or the y squared, as far as the terms are concerned. Okay. When you set these things up, you start to think about it. We're centering everything around the origin to start with. Oops, let me just move this up real quick. And if I'm centering this around the origin, if this is my vertex, again, my vertex for these will be at the a value, so it'll be at a comma 0, oops, and then negative a comma 0. There really isn't technically what you call a co-vertex for these, but I still call it that because what happens is, in order to figure out where our asymptotes go, we're going to plot a rectangle. And in order to do that, we use the co-vertex, 0, b, 0, negative b. So for example, it'll look like a dot up here and a dot down here. That will allow us to draw in a little rectangular box. That rectangular box has diagonals. Do you guys agree? Those diagonals are your slant asymptotes. Again, we'll get to that in a second, but the focus, since it's going left and right, the focus will always have the same y value as the vertex when it's going left and right. So your focus would be at c comma 0, and then negative c comma 0. We'll talk about these asymptotes in a second.
You wouldn't see the same way.
No, c's found a little bit differently here. When you did the ellipse you used c squared was a squared minus b squared. When you work with the hyperbola, c squared is a squared plus b squared. It's always the opposite of the generic formula you're working with. Okay.
So like the points are all the same, like the width, there's 8
Yeah, you still work it out that way.
Oh, and always when it's in left and right, like when
Okay.
it's like,
And then what the weird part here is when you're working with the asymptotes, if you have a left and right hyperbola, your asymptote, the equation for the line of the asymptote is going to be plus or minus b over a times x. It's written in slope-intercept form. Y equals plus or minus b over a x. The intercept of this case is 0, so they just don't write it. Later, when we get to shifting these, that part gets messy. All right, so I just want to get you guys in the habit of writing these out. The only thing that changes when this is a hyperbola that's opening up and down is that your ordered pairs are all flip-flopped, and then your asymptote is just plus or minus a over b. It just flips it. Okay. So over here, your vertex would be at 0, a, 0, negative a. This co-vertex really isn't what it's called, but I forgot what the real name of it. And again, the focus always shares, when it's up and down, it'll share the same x coordinate. And then your asymptote. Just like working with ellipses, this is a very, very straightforward generic setup. And it will not take very long for you guys to catch on. It would look something like that after you go through it. Like I said, it's very, very, very easy to plot. Okay. I know we can't see it because it's red. Sorry. Let me give you an example. Again, I'm not going to bother with graph paper, so we don't need it. So we have 4x squared minus 9y squared is 36. And it says graph, label all the important bits and pieces of the hyperbola. So it's nice when they tell you that it's a hyperbola because you know how to get it in the generic form. Remember, the generic form of the hyperbola always equals 1. So how do I turn a 36 into a 1? By not subtracting 35. Divide everything by 36. Okay? So you get x squared over 9 minus y squared over 4 is 1. So right off the bat, when you get that far, you're going to be able to tell right away if it's left and right or up and down. Is this one left and right or up and down?
It is right.
Why is it left and right? That has absolutely nothing to do with it. Yes, sir.
Because y squared is being subtracted from x squared.
Because x squared is first.
That's what I thought.
It's going to be a left-right because x squared is first. Okay? That's how you tell these things. If the y squared came first, it would be up and down. Just like we did with ellipses, what you want to do right off the bat then is label what you know. A squared is 9. Therefore, A is what? 3. Or? Good.
Plus or minus 3.
B squared is 4. That means
Plus or minus 2.
B is plus or minus 2. C squared is A squared plus B squared. So what's 9 plus 4?
13. Plus or minus 1 third.
So C squared is 13. Everybody okay with that?
Oh,
Now C is?
plus or minus 3.
Good. From that information right there, you can do everything. So we just start by making a quick grid. Since this is moving left and right, I put my A values in first. Yeah. No.
We donate.
Okay, you can donate. I'm not getting extra credit for it. All right. So there's my A values. My co-vertex then would be at B. Because what was B?
Oh, so
And now all I have to do is just make my little rectangle. Okay? Make the rectangle. Create your diagonals. And before we just go ahead and label everything else out, let's put down what we have. Well, vertex was at 3, 0, negative 3, 0. That co-vertex, that B stuff, 0, 2, 0, negative 2. And now the focus. Remember, the focus is always, when it's going left and right, it's always going to share the same y coordinate. So it's just the square root of 13 and 0. And the negative square root of 13, 0. Worst thing that you have to do now is kind of guesstimate where the square root of 13 is going to be placed. Well, square root of 13 is bigger than the square root of 9, but it's smaller than the square root of 16. 3.6, because it's closer to 16 maybe? Sounds good to me. So if this is 3, here's 4, I'll put it about here. Now the real tough part, creating the curve. That is, hug the asymptote, get the vertex, hug the asymptote. Hug the asymptote, vertex, hug the asymptote.
Whoa.
Tough stuff.
Will
Sir.
the focus be at like 3, like so it'd be before in the box? Because
No, remember your curves always open up to focus.
but
Every
it's the, we're saying it's 3.6, and why is the actual focus?
yeah,
Not the 3.6.
it is. Right. It's bigger than the 3, which is the vertex.
Oh, I thought it was 4, so I was like,
Oh, I just put a slash in for 4, so it's in between 3 and 4.
oh, okay.
That's what I was doing. Does that make sense?
Yeah.
So again, the only thing that's left for me to label here is where's the asymptote? Well, since this moved left and right, that means that my asymptote, the equation for the asymptote, would be at plus or minus b over a. And you're done. Again,
So, when you like draw it, do the asymptotes have to be like look like they are the right slope?
it's
Or if you
close-ish.
just write it, like you just write like this is the asymptote. Like I know how
Yeah,
to do
it's close-ish, but you're still, because you're gonna label out, you're gonna write out what this is,
Yeah.
you're gonna write this out. You're just rough sketching it, okay?
Okay.
You're just gonna rough sketch it on
Okay.
there.
So as long as you know what it is.
Mhm. Yeah, that's fine.
Cool.
Okay. Again, there's really not much to this. It's just a matter of getting your square roots and going through like that. Okay. Let's try another one like that. Oops. We have y squared over 100 minus x squared over 75 is 45.
That's not even that deep. Let's just add.
5 root 5.
Isn't it?
No. 5 root 3.
No, yeah. 5 root
Is this going left and right or up and down?
Left and up and down.
Which one is it?
Up and down.
Y.
Because y first.
And that's really all there is to it, guys. Since the y squared comes first, and it's a subtraction, you know it's a hyperbola, so it's going up and down. And I'm going to do this.
You can remember that because y is a taller letter.
Yeah, that works. It works. I'll give you that. It's not a bad way of thinking about it.
two. Give him that when you want. Give me the
Yeah,
cursor.
That was terrible.
It was bad.
Yeah.
It was bad.
No, it was scientifically,
Yeah.
it was,
You were way out there on that
it was
one.
all there.
At least that one is, it's a stretch.
Would it work? It's a stretch.
That was worse.
See, I can build on that. Yours, I was falling flat.
There's no cursive letters that are flat, so I can't hold on to that one.
Come on.
Alright.
Yes, strike two. One
This
more
is
and you're out of One more principal's office.
Like the backspine of some of the letters are.
Oh,
Like,
boo. Boo. So B, value of B is going to be 5 plus or minus 5 root 3. C squared is 175. Do you agree? The square root of 175 is what?
Do you have to simplify it or?
Yep. 5 root 7. How many quarters are in $1.75?
I know, you're just so
7?
That's right.
I'm gonna say 5 root 7. Quarters.
Again, go to your grid. You know it's opening left and right. Your A values should be at your vertex. So you go up 10, down 10 on the y-axis. Square root of 75, 5 root 3. Decimal equivalent of that, well, it's bigger than the square root of 64, but smaller than the square root of 81. 8.5?
8.6.
Sure. 8-ish.
Yeah. 8 point, actually, you know, it's round up to 9.
So I just have to put it between 8 and 9 on my grid. So right now we have vertex, 0, 10, 0, negative 10. We've got co-vertex, 5 root 3, 0, negative 5 root 3, 0. Focus. Well, first of all, let's draw our box. The focus, remember, is always going to, since it's going up and down, the focus is going to be higher up than the 10 for the A values. Square root of 175 is bigger than, what is it, 169 and 196, so it's got to be like 13 and change. Right?
Yeah.
13 and change, so here's 10, 11, 12, 13, 14, so we'll say it's here. Put in your asymptote. Oh, this would be 0, 5 root 7. Put in your asymptotes. It's not even close.
You tried.
Thank you. It's horrible. And then the equation for the asymptote, since it's up and down, it's plus or minus A over B now, which is 10 over 5 root 3. Uh-oh. What do you do? So 10 over 5 is what? So this becomes 2 over root 3, which is? You should be able to do that in your head. Very good. Your asymptotes are at plus or minus 2 root 3 over 3 x. Yes, sir?
Does anything special happen when A and B are the same? Like
Would-
when A squared and B squared?
Yeah, you have a circle.
But
But
it's,
they're facing the away, they don't make a circle.
When if it's an addition problem, you get a circle.
It's a subtraction, you just get
If
two
it-
halves of a circle.
No, if it's a and b are the same, you just have a slope of 1 for your asymptotes. You have a square as opposed to a rectangle for the shape that in the middle there, if that makes sense. You can have that with them both being the same with the hyperbola, with the subtraction, that doesn't make a difference. You just get a circle that's an addition. And then again, just hug the asymptote, vertex, hug the asymptote, and that's it. Again, not very scary, I'm hoping. Give you one example of working backwards and we'll call it a day, okay? Given focus and vertices, or foci and vertices, excuse me. And I want to write the equation of the hyperbola. Foci. It's the plural of focus. So first thing you want to figure out is this one going to open left and right or up and down?
Left and right.
How do you know?
X squared would come first.
Well, how do you know it's going to open left and right?
Check the numerator.
Because the,
I don't know.
guy,
X squared would come
because the
first.
focus,
But the A comes first.
the y is constant and zero.
Right.
That's why
So
that's a straight.
What happens though, if you think about it, and he's right though,
That's right.
your vertex is there. Oops. Remember, your curves always open to the focus. So you're right, it's going to be an x squared term. Plus, if you notice that they share the same y value, it also helps you with that. So since it's going left and right, it's going to be x squared or y squared first? X squared. So you have x squared minus y squared equals 1. We just got to figure out the rest. Well, vertex, when you're at centered at the origin, is that an A, a B, or a C value? A. It's an A value. So this means that my A value is 1. Focus, is that a B or a C? Nope, it's a C. Focus is a C. We'll call that 4. We got to figure out what B is. Well, A squared plus B squared is C squared. What's 1 squared?
1.
What's 4 squared? What's B squared? That's B. What's B squared? 15.
Sweet.
So, A squared is 1, B squared is 15. And you're done. You don't have to worry about taking the square root for B. You're not graphing this to figure out where the that co-vertex part's going to be at. You're just writing out the generic form of the equation.
But I didn't remember
Let me give you a couple of these to try.
Oh, murr.
I know. It's on page 619.
Break.
Part D.
Is that D or?
It's not like
Strike 1 for murr.
Do those, please.
Strike 2.
I'll get over it. Be honest with you, it won't take you very long to go through this at all. Very, very straightforward. When it says to graph them, make sure you guys graph them the way we do it in class. We label out everything, because that's kind of how I'm going to have you do it when we take the tests and stuff. Bless you. To be honest, we'll probably, bless you. We'll start doing all the shifting on Thursday, and I'll take us at least a couple of days to get through. We'll test out of this chapter sometime next week.
Did your kids